Good morning and welcome to our first video lecture on computer applications in accounting. My name is Joshua Ado. This specific lecture is to explain the notes I have given you on normalization. So I plead that before you go through this video lecture, you have your textual note on normalization with you so you can understand the lecture very well. You remember our previous lecture on database management, where we said that how traditionally we've been keeping data, also known as the flat file database management system, has a lot of problems, and we grouped the main problems about flat file data management systems into three. And if you look at the lecture notes, you will see that we have captured these three problems here. You have updating, or what is normally referred to as update anomaly. We also have delete anomaly and insert anomaly. These are the major problems with flat file data management systems. The explanation is simple. If you keep flat file database management system, where in most cases you lump multiple data or data on multiple subjects into one giant table or a few other tables, when it becomes the need to update the database, it becomes, if not impossible, extremely difficult. Deleting a record from the database sometimes leads to deleting other essential information which is not meant to be deleted, or deleting an unneeded information leaves an orphan data, a redundant data. Some data which needs to be deleted as well is left undeleted in some other table. It also becomes difficult when you have to add to such a database. And in addition to these three main anomalies, it also is a problem when you are preparing a report from such a database, most especially if the report is meant to be a little bit complex. So to save that situation, there's a new science of data management which we have already talked about, which is relational database management systems, shortened as RDBMS. The main difference between the flat file data management system, which we have already discussed, and the RDBMS is that RDBMS tries to break the tables, the database tables, into logical tables. So you'll see a lot of tables in RDBMS than traditional flat file data management systems. The idea behind breaking the database tables into many logical tables is that each table is supposed to store information on one subject matter. So the process of trying to break the tables, database tables, into smaller tables which store data on specific subject matters is what is referred to as normalization. So normalization is basically breaking up your tables or designing your tables in a logical way so that each table stores a specific data. When that is done, it has been realized that the problems above, update anomaly, delete anomaly, insert anomaly, and querying of the database becomes so flexible and becomes efficient. So that is what normalization is. And you can get it from the notes So I'm just doing explanation, I'm not reading for you to write. The process of normalization involves steps or procedures. So you go through a number of procedures or steps to finally get to your tables normalized. And these procedures are referred to as normal forms. Normal forms. We have several normal forms that you have to go through to get your database tables well normalized. But for the purposes of this lecture, we are going to talk about 3 of the normal forms. And of course, you can read on the rest. Once you can Google, you can read any textbook, you will see the additional normal forms in addition to the first 3 that we are going to discuss. The names of these first 3 normal forms are very simple. First one is called first normal form. So for your database to be well normalized, you should have, or you should be in first normal form, or your table design should conform to first normal form principles. First normal form is normally written in short form as 1NF. 1 represent first, N represent normal, and F represent form. We'll also talk about second normal form. After you have achieved first normal form, then we strive towards more normalization by also going through second normal form procedures or principles. And then finally we'll talk about third normal form. So let's take our time and go through them one by one. The first normal form basically is saying this. When you create a table, we know that table is made up of columns and rows. The columns are the first column will contain the headings under which you will capture information for each record. So first normal form is saying that in your table design, you should have at least one column that works to uniquely identify all the records in the table. I'll explain further with illustration for you to understand. So the first normal form, first thing you have to think about is the concept of primary key as a unique identifier of records. If you are capturing, let's say, a simple data like name, date of birth, and let's say hometowns of all Ghanaians, it is possible that you may get multiple people with the same name, with the same date of birth, with the same hometown. The challenge is that if you keep such a data where we have, let's say, 5 people with the same name, with the same date of birth, with the same hometown, and you need information, let's say the person's name is Josh Ado, the date of birth is, let's say, 27 December 1990, and the hometown is Abuasi. And then you have several other people with the same name, Josh Ado, the same date of birth, and the same hometown. The simple challenge is, if you are asking your database to give you information on Josh Ado, which of the many Josh Ados should the database return? because we have 5 of them for this illustration. 5 of them with the same information. So which of them? The database will be confused. So the database cannot respond to your query. In fact, in most relational database systems, the engine has been designed in such a way that once the first entry is made, any second entry which is exactly the same as the first one will not be accepted. So you have to have a way of telling the database that the first Josh Ado is different from the second Josh Ado, different from the third one, different from the fourth one. In fact, you must make the database understand that the Josh Ados, all of them are different from themselves. And the way to do that is to make one column. Sometimes you can use multiple columns to do that job, but mainly one column. Is to use one column to show a difference in all the records that you're going to capture. Let's see an example from table 1. In table 1, without this column which has the heading as student, without this column, and let's say the table has student name and date of birth and hometown, so let's say other attributes. If the table is just these 2 columns, then see what is happening. We have Josh Ado, let's say date of birth, hometown, and then the third entry was also Josh Ado with the same date of birth and hometown. And we have explained the challenge when the data is kept like that. So to follow the first principle of first normal form, which is an idea of primary key which uniquely identifies the records, there should be at least one column. So that's why we have the student column. The PK inside this bracket means primary key. So primary key is a column or a combination of columns which is to do the job of unique identification of records. So see, once we have the primary key column which contains values which are unique across all the other columns, you will see that Josh Ado here sorry, the first entry, which is Josh Ado, is different from the second entry, Josh Ado, by their primary key values, by their student values. So you see that the names are the same, but their student values are different. So the database will be able to understand that Josh Ado, they are different because this one has a student value of 1, this one has a student value of 3. And if you are querying database for, let's say, information on Josh Ado, the database could be made to understand it clearly that you want Josh Ado with student value 3, and that is just what is going to come. So that is what the first principle of first normal form. The first principle of first normal form is saying that in your table design you should have at least one column called the primary key column, that has values. The values are the data under that column that uniquely identifies the records in that table. So this 1, 2, 3 are uniquely, because 1 is not the same as 2, 2 is not the same as 3, 1 is not the same as 3. So this column is uniquely identifying all the other values, which is the student names, student date of birth, and the rest. So that is the first thing to think about when your tables must be in first normal form. The second principle in first normal form is that each columns are also referred to as attributes. That's one you know already. And more specifically, to access, a column is also referred to as a field. So each column, each attribute, each field should contain, so you can do this correction. It shouldn't be should contain atomic values. So you have achieved the first principle of adding a primary key column, which has values that uniquely identify all the records. Good. The second thing to think about to achieve first normal form is that the columns which represent the pieces of information you are going to gather for each student. So we are using this table to illustrate. So these columns, we have student name, other attributes. This is the description of the pieces of data you are going to capture on the students. So you are saying that, okay, for every student I need this information. These columns must have atomic values. It means that under each column, the value should be atomic. And you should understand atomic. It is just a direct borrowing from your science studies on what an atom is. They define atom as the basic element of a matter which cannot be divided again. So that's the same idea. The values under the columns should be atomic. The values under the column should not be compound. It should not be a combination of pieces of data. So if you look at table 1, we have violated this principle of atomic values. The column name, student name. You see the column, student's name, this column. The values under this column heading are Josh Ado, Nanajwa Sampa, and then we have another Josh Ado. These values are not atomic because if you see Josh Ado is a combination of two data values, Josh and Ado, which could be broken and each one can stand on itself. That is a violation. Each value under the column name should be atomic, should be one unit which you cannot split. So what it should have been is that we should have kept Josh different from Ado. We should have kept Nana different from Ajua, different from Sampa. When that is achieved, then we have achieved atomicity for the values we capture under the columns. So if you design your table which combines data values under one column, that is going to result in a huge problem. That is going to result in all the problems we discussed under the flat file database management system. You're going to find it difficult updating that table. You're going to find it very difficult inserting into that table You're also going to find it difficult generating reports if you keep your table designed that way. How do we resolve this problem? So once we resolve this problem, then we are now getting towards normalized, at least on first normal form principles. And the solution is simple. So make sure that each column contains one value. Each column stores values which are atomic. So it means that the column name itself should not be compound. The column name itself should not communicate the idea of storing compound values under that column. So if you look at student's name, it communicates the idea that the values that should be under that column should be compound, because a typical student has at least two names, first name and surname. Some even have more. So the solution is that we break the column into the various parts of names that we commonly use. Name is basically broken into first name, surname, and some people have maybe other names. So table 2 is trying to resolve the problems in the first table, where we have compound values stored under a column. So the solution that we have done is that we have now broken the table into the various parts of a name. So you have the student column, and then instead of student's name, we now have first name, so that we can have that atomic value for a first name, and then surname, other names, and then we have other attributes. So instead of a student name stored as Josh Ado under one column, we now have Josh under first name column, Ado under surname column. If you look at the second record, we have Ajua stored as under the first name column, Sampa stored under the second name column, and Nana stored under the other name column. This means the values under each of the column is atomic. It is in its basic form that we cannot divide again. It is not compound. Because how would you divide Ajua, for example? If you divide, it doesn't represent a name. So that's how we resolve the problem of atomic values. The third principle under first normal form is that there should be no repeating groups of columns. There should be no repeating groups of columns. And let's use table 3 to explain that. In some cases, especially if we are storing data in a flat file manner, we try to have as many data as possible inside the same table. That is what normally sends us into that problem. So let's say this particular table, the person was trying to capture the table in such a way that if we find a student, we can readily find a student's phone number, and then maybe we give a call to the student. So if you look at the table, we have the primary key column, the student, we have first name column, we have surname column, which means we have adhered to the first principle of unique identification of records. We have adhered to the second principle of first normal form, which is atomic values. But look at what is happening. The person is thinking, you see, normally people have more than one phone numbers. The person is thinking that a way to capture all the phone numbers is to do something like phone number 1, phone number 2. If the person has more than 2, then phone number 3, and so on and so forth. But if you do phone number 1, phone number 2, phone number 3, the central piece of data you want to capture is phone data, which you are dividing across 3 columns. And that's the meaning of repeating columns, because it's the same idea of phone information which you are repeating in the form of phone 1, phone 2, phone 3. That's the idea. Another example which you can give, which is, it's more about business, is where, let's say you want to keep information about products that customers buy. You want to keep information on the sales you make of your products. So basically, it's information on customers who are buying your products and the products they are buying. So you do a database table like this. So let's say you have your product ID, product name. Let's keep it simple. So product ID, let's say product ID 1, the name is, let's say, printer. Then you have customer. The customers that may buy this item of printer maybe many. It's not one person who is going to buy the printer. So you decide to store it as, let's say, customer 1, customer 2, customer 3. The idea we are trying to communicate is that this customer 2, customer 3 is the same central data of customer. So you are repeating that thing under 3 columns, which is not necessary. That's what we are saying. So in table 3, we are breaking one of the principles of first normal form, which is repeating columns. So we have phone 1, phone 2. How do we resolve it so that we get more finer into normalization? The way to do that, because the simple thing is that you don't have to repeat the column. So one of the columns should go. If one of the columns goes, how do we get that information? Another way I'll talk about that in another principle. So the way to resolve this problem is to cut this part of the table away and form them, because they are capturing the same central information of phone, or let's say more broadly, contact. Yes, that's the central data. These 2 columns are capturing data on contact. So we have to take it off. And you also remember I told you the idea of breaking tables into several other tables is to make sure that each table stores specific data. Each table stores data on a single subject matter. You see that this is not only violating the principle of first normal form, which is saying there should be no repeating groups. It's also defeating the idea of one table storing data on one subject matter. This table, for now, is storing data specific on students. At the same time, it's storing data on contacts. So it's storing data on multiple subject matters. In most cases where you have repeating values, you have repeating columns, it also defeats the idea that the table should store data on one subject matter. So the way to resolve this is to actually force the table to store data on one subject matter. So the other subject matter should be removed and formed into its own table. So we are going to take these two columns, which is about contacts, off, and then form a table which is on contacts. Later, we can make the two tables communicate with themselves when we need to generate any report which should come with the students' names and their contacts. Very simple to do. So from tables 4 and I think tables 5, we see how tables 4 and 5 is on a different thing. It's trying to also show another problem. So let me talk about the solution straight up in this form. So the solution to this problem is to do this, is to break the table, because the table is storing information on two subject matters. So break it. So we now have the first table and the second table. So we're going to generate two tables from this single table. This table is called student. So it means it's going to store student specific data. And this one is contacts, which is going to store the phone plus any other data which is contacts, if you want to add that. So these are column headings, which is student, first name, surname, and then we have, because we should have a primary key field, primary key column for this table, so we have to bring that ID. We can call it contact ID, which can be shortened as conted. Then we can have phone. So we can even bring other contact information like email and so on and so forth. Then later we join these two tables. We'll capture how we join tables when we do lectures on table relationships. So this one will be 1, 2, that is the student values. Then we have Josh, Ado, we have Joa, Center. Then we have, for here, we have, let's say, the content ID 1 is 1. Then we capture the first phone number, which is 0506028495. If there is an email, you add it. Second value into the contact table is the second number, 0246512655. Third one is 0244347140. Okay, so this is how we store it. So you see, this second table stores data on only contacts for this particular illustration, for only phone numbers. So if you look at only that table, that's the information you will see. A lot of phone numbers. But at this point, you will not know whether this phone number is for that student and this one is for the other students. You wouldn't know. So that is why we link the tables, because each number is not existing in isolation. Each number is linked with the students. But for the purposes of achieving the principles we have already discussed, this is how we have to design the tables. Then a way to resolve the idea of making or linking the numbers to the students whose numbers we have captured is to do table relationships. Table relationship is simply done by the idea of primary key and a foreign key. Primary key and a foreign key. So let me give an overview. What I'm doing right now is giving you an overview information on table relationships. We'll have a lecture solely on that. This table, these numbers here, are for some people, and the people are in a different table. So a way to link them, which is the relationship, is to create another column called foreign key column. And a foreign key column is simply copying the primary key column in the student table and pasting it inside the contact table. The reason why it is called a foreign key is that you are bringing a column which belongs to another table into a different table. So in that different table where it doesn't naturally belong, it is a foreigner. So that's the idea of a foreign key. So when we add student, we know that student or student ID column, which is this one, it belongs to the student table, but we are bringing the same thing here. So student, it is a foreigner here, so let me put into bracket foreign key. So that's the idea behind foreign key. So when you are capturing the data, so 0506028495, which is content ID 1, you also have to add the foreign key number, which is the student number, which is coming from the student table. So if I put 1 here, the idea is that I am associating this number with this ID to this person in the student table, because this person has the student value 1. If I put here 3, it means I'm associating this whole record to a third person. Let's say this is part. I'm associating this entry with this particular person in this table. That's how we do the table association, and we'll have a whole lecture on that. So this is to give you an idea of how you resolve this violation of repeating columns. The way to resolve it is to break the table into different tables storing data on one subject matter, and then you link the tables. So that's how you resolve it. Some people may think of not storing the data in this way, which results in repeating values. Repeating columns from 1, from 2. They might think that, well, either this way of storing data is not nice, or maybe they have an idea of repeating columns not too good. So they decide to keep 1 column, which is fun. And then as under that 1 column, they try to compress or store all the numbers under 1 column. Let me just be clear. Let's use this table 4. So what the person is doing is that this student with student ID 1. The first name is Josh, the second name is Ado. That person has at least 2 phone numbers. So the phone information is captured under the column heading phone, and see what is happening. The first number is captured, which is 0506028495. Then the second number is also captured under that same column, but separated by a semicolon. And you see this way of storing information in many places. This is a violation because the 2 values of 0506028495 and 0246512655 are not helping us achieve the principle of atomicity. Yes, because this value is not atomic. It's 2 numbers stored at the same time. That is not atomic. At any point in time, there should be 1 value stored. So this is a violation of one of the second first normal form principles. In addition to that violation, you also that broader principle of a table storing data on one subject matter. This is also violated because this table is storing information on the students plus information on contacts, which is logically two pieces of subject matter. So it is almost the same as the repeating columns, because here we have repeating values under the same column. So repeating values under the same column and repeating columns all present the same problem. And a way to resolve that problem is the same as what we did. So we break the 2 tables, and you can see it clearly here. It's just like what I illustrated on the sticky note. We break the 2 tables, so we now have a table which stores student specific data. And then we have the second table which stores contact specific data or information. Then we link the tables together. So if you look at it, the tables have been separated into 2 tables as we discussed. And then the idea of a foreign key. So the foreign key is added to the student table. So we have content. The content actually is the primary key of the contact ID. So once it is brought into the student table, it acts as a foreign key. We could have also brought the student into the contact table, and I think that is more logical. So actually what should be done is this. So let's delete this column. Okay, and rather insert another column into here. Then let's copy this one and paste here. So this is the foreign key. The reason why I'm doing it this way is that it makes more sense that if I will first probably enter the student table with these values. When I'm entering the phone number values into the contact table, after this entry, the first entry, then I associate this, or I specify who this number is for. So it makes more sense to actually bring the foreign key here. So I'll say this is for student ID 1 because it's for the first student, which is Josh Adam. Then this one is for the same person, 1. And this one is for the second person, 2. Yes, this is how we resolve it. It's the same as the first one we did. So these are the key principles to follow if you want to achieve first normal form in your table design. 1. Your table should have a unique identifier column known as the primary key column. 2. Your table should not have repeating columns, something like customer 1, customer 2, customer 3. The concept is customer. You can have it in repeating groups or columns. You shouldn't also have a column with multiple values under that column, like this one. We shouldn't have something like this. We should not have something like this. That under this column, for this particular student, we have one phone number stored again with a second phone number and possibly a third phone number. No. So there should be no multiple values. Every value should be atomic. This is not atomic. This is compound because it is 2. And third, okay, so these are the main things we have captured under first normal form. And a way to resolve the violation of repeating columns or repeating values is to move the columns that are repeating into a separate table, which is later linked with the main table. So that's what we have captured so far under first normal form. First normal form. So everybody by now should be very conversant with first normal form principles. I wish to end the video presentation here so that you can have time to assimilate what we have said. It will be quickly followed with video recording on second normal form and third normal form. Maybe I'm going to break it in 3 separate videos like I've done for today. So this video is solely on first normal form. If you have any questions or any additions, any comments, anything, you can contact me. You already have my phone number. You can contact me for maybe further clarification or for additional information or whatever it is. So thank you very much.